Dear students, in previous lecture we have seen two experiments performed by the Foucault, how the eddy currents are produced, and second experiment, the electromagnetic damping we have observed. What is electromagnetic damping? So instead of the free oscillation of this metallic plate, so there is some opposition due to the change in the flux. So that's why eddy currents are produced. The eddy currents produced in such a way that according to Lenz's law it will oppose the to increase the flux in it. So that's why the metallic plate will come soon to rest. So to reduce that damping effect, what we should do is, so it may ask one more question, how to minimize the eddy currents. So this is the one method to minimize the eddy currents. That method we'll see. Instead of taking the full metallic plate as we have observed in previous case, so now we have taken the metallic plate having the narrow slots, and again it is suspended between these poles of the strong magnet. So when this metallic plate is made to oscillate, it is found that this metallic plate is oscillate more freely in this case as comparing to previous case because of having these narrow slots. So why this why this oscillation is more freely as comparing to previous case, now we'll see. So here previous case also eddy currents are produced, now also eddy currents are produced due to the change in the magnetic flux linked with this. So here if you compare the magnitudes of eddy currents in previous case, now the eddy currents produced in this case are much less. Why? Because here this path of the means the current magnitude is less. I'm telling why, because so when the electric current is produced generally due to the motion of electrons, so here also the induced current is produced due to the flow of electrons. So flow of electrons, it is opposite to the flow of a current, so electrons traveling in this direction. So if you see previous case, now the electrons traveling the distance more in this case because of having these slots. So if you see the electrons traveling in previous case directly, instead of this having the slots directly, the electrons covering this distance like this. So now the electrons covering the distance more because of having this more slots. So during this more covering the distance means electrons traveling the more distance in this metallic plate. So while traveling the more distance in the metallic plate, there is more resistance offered by the metallic plate to the electrons. So there is a more resistance means the current's magnitude becomes less. That's why current induced current or this eddy current's magnitude becomes very less. That's why this that opposition offered means that opposition due to this change in the magnetic flux also it will be less. That's why this metallic plate it will be oscillate more freely as comparing to previous case. So what is the difference between previous case? Now just in simple way we will discuss once again. So here I have taken the metallic plate having the narrow slots. Due to having these narrow slots, again the induced currents are produced. The magnitude of induced currents produced in this case are very less because electrons has to travel the more distance. During this distance, the electrons experiencing the more resistance. So as a result, the eddy currents produced are smaller. So that's why this is the one of the method to minimize eddy currents or to reduce the electromagnetic damping. So now we'll see the applications. So this is also one of the important questions. Applications of eddy currents. So here first application, electromagnetic damping. Second one, induction motors. Next, speedometer. Next, energy meters. Electric brakes. Next, induction furnace, etc. So here this question is important for 3 marks. Mention any 3 applications of eddy current. So any 3 you can write. And here there are some undesirable effects of eddy currents. Undesirable effects of eddy currents. What are that undesirable effects? We'll see. Here the resistance of the metallic conductor is very low. The magnitude of eddy currents produced are quite large. So in second experiment we have seen there is a metallic plate we have taken. So in that case resistance of the metallic conductor is low. If the resistance is low, the magnitude of eddy currents in that case it will be very large. So as a result of this, the amount of heat is produced due to large value of eddy currents. So large value of eddy currents because of a low resistance. So due to the large value of eddy currents, considerable amount of heat is produced in the conductor. So if these eddy currents are large to produce in this metallic conductor, so there is a considerable heat it will be produced. So this is one undesirable effect. So here this undesirable this amount of heat generally due to the eddy currents produced like in transformer or dynamos. So this is one of the undesirable effect. The amount of means unnecessary heat it will be produced due to the large value of eddy current having the low resistance in that metallic plates.